Good morning, everyone. We're from 8A. Today, we're going to present about measuring the quality of water. My name is Anna Benjaviva.
My name is Kasura Simon Barako.
My name is Laksika Tiathawanchai.
My name is Marisara Jongnaramsik.
My name is Thikarit Yirapanapho.
And my name is Kuntarini Dendarachol.
First, we're going to talk a little bit about water. The first topic is temperature. Temperature can determine the rate of biochemical reactions in the aquatic environment or whether they can occur at all. It affects the solubility of dissolved oxygen, rate of plant growth, metabolic rate of organisms, and resistance in organisms. The next topic is pH. It is the scale used to measure the acidity of water. Small changes of pH can endanger many kinds of plants and animals. The expected pH levels of water are as follows. Lakes and streams, pH 7 to 8. Drinking water, pH 6.5 to 8.5, and areas with higher levels of water hardness, pH 7.5 to 8.5.
The third topic is turbidity. Turbidity is the measure of water's lack of clarity. Water with high turbidity is cloudy while the water with low turbidity is clear. High turbidity decreases the amount of sunlight able to penetrate the water. When water is cloudy, sunlight will warm it more efficiently because suspended particles absorb the sunlight. Turbidity is measured in nephelometric units or NTU. The standard for drinking water is 0.5 NTU to 1 NTU.
The fourth topic is water hardness. Hardness can be measured as calcium hardness or total hardness. Excess calcium and magnesium ions contribute to water hardness. An obvious sign of water hardness is a layer of white film deposit on surface. The term hard water comes from the fact that calcium and magnesium ions in water combine with salt molecules to produce salts, resulting in a layer of white film.
The fifth topic is total dissolved solids. Solids are found in streams and lakes. They can be separated into two forms, suspended and dissolved. The expected levels are as follows. Number 1. Total dissolved solids in lake and stream 250 mg per liter. Number 2. In area of especially high salinity, total dissolved solids may be as high as 500 mg per liter. And number 3. Drinking water tends to be 25 to 500 mg per liter. The next topic is BOD. BOD represents the amount of oxygen which is consumed in the aerobic process of decomposition of organic materials by microorganisms. When BOD levels are high, DO levels decreases. BOD is stated in milligram per liter. BOD can be measured in 5 days. BOD levels are 1 to 2, good, 3 to 5, fair, 6 to 9, poor, and 100 or greater, very poor.
The last topic is normal and mineral water. The water that comes from nature is called normal water, and the waters that contain minerals is called mineral waters. It provides many benefits such as improved bone health and reduces kidney stone risk. Sodium can also help to absorb water and also help to break down waste material.
The first experiment is about measuring the pH of water. Materials are types of water, universal indicator, test tube, rack, and dropper. The procedures are: first, put each can of water that you want to test into a test tube and put them in a test tube rack. Next, use a dropper to drop about 5 drops of universal indicator into each test tube.
Then check all of the test tubes and make sure all the universal indicators is mixed thoroughly. Lastly, put all the test tubes back into the test tube rack and wait for the reaction to occur.
Conclusion: Drinking water is usually neutral, but if the water contains minerals, it will change its color to dark green or blue. Acid rain or rain and swimming pool water are acid, and tap water and the fish tank water are weak alkali.
Next, we are going to test hardness and minerals in water. The materials are a dropper, a hardness tester 1 and 2, a test tube, and a water sample.
First, put 5 milliliters of different kinds of water into different test tubes. Next, add 1 to 2 scoops of the first tester into the test tube, and the color will change to yellow to orange. Then add the second part of the hardness tester, drop by drop.
The observation is mineral water use a lot of drop to turn its color to green, but drinking water or water that has less calcium use less drop of solution to turn its color to green.
Conclusion: Water that use lots of drops to make its color change has lots of calcium molecules, which cause hardness in water. This shows that mineral water has minerals such as calcium. But too much calcium isn't good too, so in water should have an appropriate level of calcium.
Note: Total hardness equals the amount of drop multiplied 70. Too much of calcium could lead to the increased risk of osteoporosis, nephrolithiasis, kidney stone, colorectal cancer, hypertension and stroke, coronary artery disease, insulin resistance, and obesity. That is for our presentation. Thank you for listening.